All right, so question number 8 says the following diagram shows the graph of y is equal to x squared plus x minus 2. So here's what we're asked. So we're seeing the graph. Now from the graph, state the root of the function. So the roots of the function are the values of x for which the function is equal to 0. The roots are the x-intercepts. So the x-intercepts are here and here. So the roots would be x is equal to minus 2 and x is equal to 1. So the roots are x is equal to minus 2 and x is equal to 1. Now the coordinates of the y-intercept of the function, the y-intercept is where the graph cuts the y-axis. The graph cuts the y-axis here. So that is the y-intercept. The value of x is 0 and the value of y is minus 2. So this is the line x is equal to 0. The y-axis is the line x is equal to 0. And the horizontal line that that point is on is y is equal to minus 2. So 0 minus 2 is the y-intercept. The minimum value of the function, all right, and we're using the graph. The minimum value of the function is in the dead middle between, so here is the minimum value of the function. As a minimum value, it just passed 2.2468. No. So this must be 2.4, 2.4, 2.8, 3.2, 3.6. So this is actually minus 2.4. So the minimum value of the function y min is actually minus 2.4. The equation of the axis of symmetry. Remember, the axis of symmetry is the vertical line through the turning point. So we can all see that this line here is the axis of symmetry. And this line looks like, all right, just give me a second to draw it properly. It's about there. It looks as if it's minus 0.5. X is equal to minus 0.5. Thing is buffering a little. So x is equal to minus 0.5 is the line of symmetry. B, on the same pair of axes on page 24, draw the line y is equal to 2x plus 4. Well, y is equal to 2x plus 4 is a straight line. So we need to draw a straight line. Y is equal to 2x plus 4. All right, so y is equal to 2x plus 4. Remember, we need 2 points to draw a straight line. I could go after the intercepts. So the y-intercept is when x is 0. I'm going to get y is 2 times 0 plus 4, which is 4. So 0, 4 is the y-intercept. Remember, I need 2 points or a straight line graph. I can then go after the x-intercept. And this is when y is equal to 0. Of course, this is not the only way that this could have been done. So I'm going to have 0 is equal to 2x plus 4. Minus 4 would be equal to 2x. Divide both sides by 2. And we get x is minus 2. So this point is minus 2, 0. So minus 2, 0 and 0, 4. Minus 2, 0, that would be here. And 0, 4, that would be here, are 2 points on the straight line. So let's draw a straight line through these 2 points. All right. So now that we have done that, we have the line y is equal to 2x plus 4. Next, using your graph, determine the solutions of the following pair of simultaneous equation. So this is what we would have told you. To use graph to solve simultaneous equation, you must draw the graph of the two equations, and the solutions are the values of x and y where the two graphs meet. So let's go. We want the solutions. Now we already draw, I know we already draw y is equal to 2x plus 4, and the quadratic graph was given to us. It's y is equal to x squared plus 2x minus 2. So the solution are the values of x and y where the two graphs intersect. They intersect at 3, 10 and at minus 2, 0. They intersect at minus 2, 0 and at 3, 10. So my solutions are x is equal to minus 2, y is equal to 0. X is equal to 3 and y is equal to 10 are the solutions of the simultaneous equation. Again, when we use graph to solve simultaneous equation, we draw the graph of both equations, and the solutions are the values of x and y where the two graphs intersect. C. At C, we're told that the following diagram shows the velocity time graph of a car's journey from town R to town Q. The car accelerates for 2 minutes, traveled at a constant maximum speed, then slows to a stop. All right, the car travels accelerates for 2 minutes, only for 2 minutes, or accelerates for 2 minutes. Okay. All right. Then constant speed, then slows to a stop. Okay, fine. Determine the initial acceleration. Well, the initial acceleration for a speed time graph, acceleration is gradient. So the initial acceleration would be the gradient of this line. This is 120, 30, and this is the origin, which is 0, 0. So the gradient, which is the acceleration, it's 120, 30, good. The gradient, which is the acceleration, which is the gradient, is equal to y2, which is 30, minus y1, which is 0, over x2, which is 120, minus x1, which is 0. So this is 30 over 120. This is a quarter, and this is meters per second. Meters per second per second. So this is a quarter meters per second squared. Now we're to calculate the distance between the two towns. Well, calculate the distance between the two towns. Calculate the distance between the two towns. Well, the distance between the two towns would be the area of this entire shape, because this diagram actually represents the journey. For a speed time graph, area under the graph represents distance. So since this graph represents the journey from one town to the next, the area under the entire graph represents the total distance traveled. All right, so this is a trapezium. Let's get some measurements. At the bottom, this is what, 840. 840 because it's going up by 60. So this is 840. Each centimeter is 60. 1, 2, 3, 4, 5, 6, 7, 8. So this will be 480. 60 times 8. And the height, h, is 30. So the distance traveled is equal to area, which is equal to a half a plus b times h. It's a half. A is 480, b is 840 times the height, which is 30. So our final answer is 480 plus 840 times 15. This is 19,800 meters. Or if we want, we could say this is equal to 19.8 kilometers. So the distance between the two towns is 19.8 kilometers.